Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 19 of the January daily LeetCode challenge, and we have a very good question in front of us. Okay, this question is going to revolve around the topic of, you can say, like, we can either solve this question using the graph approach, okay, or we can solve this question using the heap approach. Okay, so the approach that I will be showing is going to be the heap approach. This is a hard question. As you can see, the acceptance rate, this is going to have acceptance rate of around 54%. This is one of the lowest acceptance rates that we could see. Okay, so 50% is actually very less in terms of lead code. What I can say is, okay, so this question is going to be, as you can see, it's a marked as hard question. And see, there are multiple ways to solve this kind of questions, but the idea here is the constraint that they're giving. Okay, see this part, they are giving, see, it is going to be 200 cross 200 grid. At the same time, the values are going to be huge here. Okay, so idea here is, if you are not using the most optimal approach, your solution will not be accepted. Okay, so yep, you can try using graph. Okay, I tried actually multiple ways to solve it using graph, but my solutions were not getting accepted. For that reason, I am not able to show any graph approach today, but I will show you the heap approach. Okay, this is going to be very interesting question. So yeah, please, yeah, pay, proper attention. I'm sure that after end of this video you'll be learning something new, something amazing. Okay, because see, this kind of questions, if you can definitely say that this is going to be a FAANG level question, especially something that could be asked by Google. Okay, so see this part, how hard it is, and like many people were not able to solve it, and because there are, see this part, you can create a solution, but it is not able to solve all the test cases in the limited time. Okay, it will be time limit exceeded. That is the only thing that is causing a lot of trouble to many of the coders. Okay, so let us begin with this question. And one more thing is, see, this is among the first 500 of questions of LeetCode. Remember, first 500, or you can say, for that reason, first 1,000 questions of LeetCode are called the golden questions, because there is a lot of content in them. Okay, there is a lot of coding and a lot of content, a lot of imagination involved in them. Okay, so please pay attention whenever you're getting a question which is below 500 for LeetCode. Okay, so this is one among them. Trapping rainwater, it is a part of that question. So if you want, you can even try the part one of that question. That is kind of a 2D question, but in this they have made it as a 3D question. Okay, this is going to be very, very interesting. Given m cross and matrix height map, okay, representing the height of each unit cells in a 2D elevation map, return the volume of water it can contain, that it can trap after raining. Okay, so again I will repeat, see this part, we are given m cross and matrix. Okay, which, see, each value in this matrix, see, this is going to be 3 cross 3 sorry, 2 cross 2 matrix. Each value here is going to represent the height of the that particular cell. Okay, that particular cell, what is the height, right? They are calling it as a height map, representing the height of each unit cell in a 2D elevation map. Okay, return the volume of water it can trap after raining. So see this part, the diagram is actually a very good one. As you can see, without this diagram, I guess it will be very difficult for you to understand, and for me also to show you. Okay, so see this diagram. So this map tells me that what is the elevation for each cell, and this diagram shows me how it looks in a 3D. Okay, now the idea here is, from top, it will be raining, and then wherever there is a cavity, when I say cavity, it means there is empty space surrounded by some blocks. In that case, it is creating a cavity, so that will trap some water. So you will have to tell me how much water could be trapped. One more thing that I want to tell you well ahead of time is that, see this part, the adjacent, that is the boundary cells. If you see, there is nothing beyond that boundary. Please see this point. They have not mentioned this point here, but without that, if you try, you will not be able to solve it. Okay, so see this part also. In the boundary cells, for example, if you see this part, this particular cell, that is here, this particular part I'm saying, see this part, there cannot be water trapped here. Okay, because if you see, after this grid there is empty space. Just imagine like that, after this whole grid there is going to be empty space all over. So adjacent cells are not going to trap any water. Okay, I'm sorry, not adjacent, I mean the boundary cells. Boundary cells means the cells which are, at the end of the grids. Okay, at the border of the grids, the border cells, I can say, they're not going to trap any water. Okay, because of this reason, because either on one side or on two sides they are not going to have any boundary. Okay, for that reason, any water cell is not going to trap any water. Okay, because just imagine like this particular structure is there, and this is like flying in space, you can think of it something like that, and there is no, nothing surrounding this. Okay, so if you're trying to capture something in the water cell, that will not be possible. Okay, as simple as that. Now, how to trap, see this part, this is example number one. In this, if we see, is these particular cells, okay, where you are seeing this blue color, water is getting trapped there. Okay, so if I can show you in this map, see this part, these two cells are trapping water. Okay, so yep, this cell is, see here, so what are the adjacent cells for this? For this, if you see, the adjacent cells are here, this side is 3. Okay, on top of that it is going to be 4, and bottom of that is going to be 3. So idea here is, it is going to trap 1 unit of water. Similarly, if you talk about this particular cell, it is going to trap 2 units of water. Okay, because its current height is 1, it is going to trap 2 more units of water. Okay, 2 more heights, you can say, like, units of water in terms of height. Okay, yeah. and then if you talk about the last, it is going to be this. Okay? So if you see the adjacent cells of this, at the right of it is going to have a 4, at the top of it is going to have a 3, and similarly at the bottom of it is going to have a 3. Okay, as similar as that, and this left side also is going to have a 3. So for the reason this node is also going to trap 1 unit of water. Okay, as simple as that. Okay, so that's why the answer is going to be 4, because it is going to be 1 plus 1 plus 2. Okay, so this particular cell is going to have 2 units of water, this one and this one is going to trap 1 unit of water. Okay, as simple as that. Now how to solve this question? So you can go through other examples also. It's like the diagrams are really good, you can go through them, but only thing that I want to tell you is that, see this part, it is going to be 200 cross 200 grid. Okay, which is, okay, we can say small, but see the values here. So see, one approach is that you can try, like I'm giving certain hints, but yeah, I'm going to show you only the heap solution. But certain hints could be that, try the simulation approach. What is simulation approach? The idea here is, if you simulate, like, see, just imagine if water is ending, what could happen? First of all, whichever is the lower, like lowest area surrounded by, that is lowest cavity, you can say, that is going to be filled first. So you can do that kind of simulation. But the challenge here is, see this part, the height map, that is the worst case scenario, that is how long a particular cell could be. It is around 2 into 10 power 4. So if you simulate one by one unit, like at the rate of 1 unit, it is again going to exceed the time limit. Okay, so that is another challenge that we're having. If this number been around some 100 or 150, something like that, then again simulation would have been a very good solution. Okay, you would have tried the simulation way. Okay, but with that, because the current question is having this very high. Okay, the height of a current cell is going to be very, very high in the worst case. That is not possible to simulate that. Okay, unit by unit. Okay, that is another challenge. So like how our approach is going to be. Okay, I am going to show the heap queue approach. Believe me, it is going to be very, very easy to understand. So what I am going to do is, see this part. First of all, we will be, we are maintaining a heap called a boundary. Okay. Idea here is which cells are going to act as a boundary. So currently, any cell that is, surrounding you can say, like, whichever is present the border. Okay. We are having 4 borders here. Okay. Boundaries or 4 borders, whichever we call it. We are having 4 such rows here. Okay. So what if you see, what is that? That is the row number 1 and the last row, similarly column number 1 and the last column. Okay, so these are the you can say various like group of cells which are acting as a border. Okay, which are acting as a boundary. So first of all, we are going to insert them in my boundary cell. See this part. First of all, I'm capturing the length. Okay, this is going to tell me how many rows are there. Then I'm capturing the m, which is going to tell me how many columns are there, right? Then I'm creating a boundary array. Okay, this is going to act as a heap. Remember, I'm talking about minimum heap. Okay, so maybe, like, let me write it here. It is going to act as a minimum heap. Okay, min heap. Like, then the wizard says, so whichever side, like, nodes I've already visited. See, idea is very simple. See, please try to keep this thing very, very simple. Whenever I insert a node in the boundary, I am supposed to add it in my visited set also. Okay, this is the logic that I'm going to follow. Okay, so whichever node you are going to add in a boundary, you are also going to mark that set. You are going to add that particular node, that is x comma y, in the visited set. Okay, as simple as that. So that we do not come and like again process the set, again process the nodes. Okay, as simple as that. So my logic is very simple. Whenever I'm going to add a node in the boundary, I will also be adding it to my visited set. Okay, so that I do not visit it again, as simple as that, right? So first of all, I am trying to add. Okay, as you can see, like, I am trying to add the first two. First of all, see this part, the first 2 columns, that is the first column and the last column, and then the first row and the last row. Okay, that's what I'm going to do now. Okay, as simple as that. This is for first column and last column. This is for first row and last row. Okay, just I'm going, what I'm doing is, I'm going through that range. Okay, and then this is, this will tell me that, see, this is talking about column 0. Okay, and this is talking about last column. Similarly, this is talking about row 0, this is talking about last row. Okay, so each value in the first column, last column, and first row, last row will be exactly inserted once. Okay, inside the boundary set. Okay, what I'm inserting, see this part, this whole element is going to be a single element in my heap. Okay, that is a single element in my heap. Okay, in a single element in a boundary array. So what is this? The first value telling me, like, this, for this particular index, what is the height. Okay, exactly whatever value you are having in the height map, we're just using that. Okay, the other one is going to tell me what is the x coordinate, the other one is going to tell me what is the y coordinate. Okay, so if you talk about it, it is going to be something like, so each cell in the heap is going to be height comma x coordinate comma y coordinate. Okay, so let me copy this part here as well. Okay, so this will tell me okay, this is the convention that I'm going to use. Okay, first value is going to tell me the height. Okay, the second value is going to tell me the x coordinate, the third value is going to tell me the y coordinate. Okay, as simple as that, right? So see, so whenever I added a node in my boundary, I'm going to add that set, sorry, that node in my visit set also. Same is the case here, same is the case here. And then when I talk about row wise, that is, I'm talking about 0th row and the last row. Okay, so whenever I'm adding all the elements in those rows to my boundary set, I will be adding them to the visit set also as soon as I enter them in the boundary node. Okay, boundary array. Fine, now starts the real calculation. See this part. Since I've see, currently it is not behaving like a heap. Okay, it is just a array, right? Just a list. So currently I'm calling the heapify function. Heapify function will like make it behave like a mini. That is, it will do that particular you can say that algorithm. It will apply the algorithm, and now it will, from here onwards, it will be behaving like a heap. Okay. So zero min heap, remember, it's a min heap. So what is a min heap? Min heap will ensure that always the node with the smallest height is at the 0th index. Okay, so whenever I pop, the node with the smallest height is going to be popped first. Okay, as simple as that, right? Then I'm just creating this direction array to visit all the adjacent cells for a possible cell. Okay, this will be used for all the calculations. Okay, so whenever I'm at a particular node, to visit its adjacent nodes, I'm going to use the direction array. So like if you have seen my other previous, you should be used like you should be very much familiar with this. This will tell me, for example, see here, I am, let us say, going to visit to the left node. Similarly, this is for the right, exact right node. Okay, right node towards the neighbor. Okay, similarly, this is going to be one node below the current node, and this is going to be one node above the current node. Okay, as simple as that. Now this is going to be my final answer, and I am initializing this with 0. Okay, so till there is a single element there in my boundary, this particular while loop will continue. Okay, so currently I'm doing a pop. Okay, what is a pop? Pop will ensure that the node with the smallest height is popped. Okay, so and for that particular node, whatever is the x and sorry, just a second. Yep. For that node, what is the x and y coordinate, that will also be getting. We are also going to get that. Okay, so this is how I am capturing it. So I'm going to capture the height for that node, which is going to be the smallest particular height, and then x and y coordinates for that. Okay, I'm just printing this particular statement for you, so that you understand how the like how the progression is happening for this code. So while you segment, please ensure that you are commenting out the print statements. Otherwise, you will get output limit exceeded error. Okay, as simple as that. Right now, so since I am now at a particular node x comma y, and I know the heart of it, and I am sure that this is going to be one of the smallest particular node. Okay, I have visited till now. Okay, among all the unvisited nodes, this is going to be the node having the smallest height. Okay, so I'm now going to visit all the adjacent cells of the current node. Okay, so what I'm doing, I'm just going for I comma j in direction. That is, see, I'm going to go through all the four adjacent cells of the current node. Okay, then I'm calculating the new coordinates. This will tell me the coordinate for the adjacent nodes. Okay, so what I'm doing, for the current node x and y, I am getting x plus I and y plus j. Okay, that is, to x I'm adding I, and to y I am adding j. Okay, so this will give me double x and double y. This double x and double y is going to tell me which see, this is the coordinate for the adjacent nodes. Okay, there are going to be four adjacent nodes for each of the cells. Okay, so this is one such coordinate for a x comma y. Okay, this is the adjacent node for that. I'm just checking. See, it is also possible that the x comma y, or any one of them, so let us say double x or let's say double y, any one of them or both of them is outside the grid. Okay, for that reason we should not be entertaining them. So I'm just checking if double x not in range of n or double y is not in range of m. In that case, we'll have to continue. Let us go to the next loop and see, because this element is not no use, right? This is not even element. For that reason, I'm just going to the next adjacent node in that case. Okay, just continue, go to the next iteration of this file loop, for loop. Okay, as simple as that. Okay, adjacent cell is out of the grid. Yep. Let me remove this part. This is not needed here. Okay. Yep. Next, if my this particular node, okay, double x double y, if this is already there in my visit, okay, remember that whenever we add a particular node to the boundary, we are also adding it in my visit set. Okay, so I'm just checking if, just a second. Yep. If double x and double y, this particular node, basically, okay, this whole thing is going to be acting as a node. Okay, if this there in my visited set, I am again going to continue, because adjacent cell has already been visited. Okay, so it's already there in my minimum heap. I should not be again and again inserting the same element. Okay, as simple as that. Next, now comes two possible cases. Okay, these are the two possible cases. So remember what we have done till now. We have popped a node whose height is going to be height, and nodes are x comma y. Now for that x comma y, I am going to visit all the four adjacent nodes. Okay, so now I'm at one of such adjacent node. Okay, this is going to be a legal node because these conditions were not true. So this is double x and double y is going to be a legal node. At the same time, it is not already visited. So like when we are coming at this particular code, remember what is happening. Double x double y is going to be adjacent cell of x comma y. At the same time, double x double y is a valid cell. It is not outside grid, and it is not visited previously. Okay, so these are the some things that these some of the things that have happened till now. Okay, now these are going to be two conditions now. Okay, what are those two conditions? Let us see. So if height of the double x double y, okay, if height of the double x double y is less than the current height. Remember, current height is the among all the unvisited cells. Okay, this height is the smallest. So if we are having adjacent cells whose height is even smaller, what is something that we can conclude? We can conclude that this particular cell can store some water definitely. Why? See this part again. I will repeat. See, this is where the logic comes. Till now, whatever you've seen is just the background. We have not started the logic till now. So what I'm going to teach you now is the logic. See this part. we are using a heap. Heap will see what is the sorting happening based on. The sorting is happening based on the height. Always remember, whenever inserting a multi-element node, so always the sorting will happen based on the zeroth element. Okay, so the zeroth element here is height. So whichever node has the smallest height, okay, remember among all the unvisited nodes, whichever is having the smallest height, that will be popped out first. Okay, as simple as that. That will be popped out first. Now, since it is sure that it is the smallest height, so we can conclude that if any adjacent cell is having a height less than the current height, that is always going to trap some water. Okay, how much water is going to trap? See this part. So this is the amount of water that is going to trap. So what we are doing, height of x comma y minus height of the adjacent cell, that is double x double y. Okay, height of x comma y minus height of double x and double y. So this is the amount of water that it will be trapping. So I'm adding that amount to the trapped water unit. Okay, so remember, this we initialize with 0. So this is also going to store how much water at each step we are going to get. Okay, at each node we are going to save. Okay, as simple as that. So this calculation tells us like how much water is being trapped at this particular node. Okay, next, see this part now. I'm just adding this print statement so that you can get to know like which particular cells are going to trap the water. This is just for remember, when you are submitting the solution, please comment out these print statements. Otherwise, you will have some disadvantages in terms of time complexity. At the same time, your output limit exceeded error can come. Okay, so just comment these statements out like this, and then only you should submit the code. Okay, as simple as that. But yeah, just for running the code, it's fine. But while submitting, you should be commenting them out. Okay, right now. See this part. Since the current node has been processed, okay, I've already processed this node. That is, I have already stored some water in this node now. Okay, so I can add it to the heap. So see, whenever we are adding something to the heap, just understand what is happening. Now this node, since okay, it is guaranteed to have some water. So this node is now going to act as a boundary for some other node. For that reason, we are going to push it inside the boundary heap. Okay, so what we are doing, this is the name of the heap, and this is the element to be pushed. Okay, so see this part. Since height of double x double y, okay, was less than the height of this, so we raised it height. See, this height now will be equal to height of this because we have now stored some water in this. Okay, so for that reason, remember what we are going to pass now. This height will no more be passed. This is the height that will be passed for double x and double y. So see this part. Now we are passing height for double x and double y. Remember, this height is greater than the previous height that it had. Okay, as simple as that. Okay, right. Now let's say if this condition is not true, what will happen? This condition not true means either the height is equal to the height, see, that is height in double x double y is equal to height in x comma y, or height in double x double y is greater than the height in, okay, x comma y. For that reason, what you have to do, see, we cannot do anything here. At least we are not going to get any trapped water in this case. Double x and double y is not going to trap any water because it's already having a height greater than the current height. Okay, greater than the height of x comma y. For that reason, we are just going to push it to the heap so that it can act as a boundary for any of the adjacent nodes. Okay, so we are pushing them as it. Remember here, the actual height was height map of double x double y, but we passed height. But in this case, since this node is than else condition, right? Else condition means this particular value is higher than this particular value. For that reason, we are going to pass the higher value. So we are in this case passing height of x comma y and the x coordinate and y coordinate. See the difference here and see the difference here. Okay. Okay, as simple as that. Now, as I mentioned, whenever you are pushing something into the heap, that is whenever you're adding element to the boundary array, what you have to do, you have to add that node in the visited set. So this is going to be the node. Okay, this is called a tuple in Python. This also acts as a single element. Okay, so this is the element what I'm highlighting now is going to be added to the visited set. Okay, so this is being used here. So whenever a cell is already visited, that we're not going to visit again. Okay, as simple as that. Because it's already either it's already there in the boundary array, or it has been processed already by the boundary array. So we are not going to push it again. Okay, as simple as that. So this value will keep continue till we have a single element left in the boundary. Okay, boundary array, and then finally, like, each node will be popped out. For that node, we are going to go through all the adjacent cells, and then we are going to determine whether the adjacent cells can store some water or not. If it could not store water, or even if it could store water, in both the cases we will change its height and insert it into the heap, that is the boundary array. And finally we'll mark them visited in the visited set. After that, when all the nodes are processed, what we have to do, we have to simply return the return trapped water. Okay, so let me quickly show how it works. So see this part. This is for example number 1. Okay, as I mentioned, which are the cells going to store water? See this part. This cell, this cell, and this cell. Okay, so what are the coordinates? It is going to be 1 comma 1, 1 comma 2, and 1 comma 4. Okay, so see this part. So 1 comma 2, as you can see, it is going to store the water. 1 comma 4, as you can see, it is going to store the water. And 1 comma 1. Okay, as simple as that. So these are the three cells which is going to store the water, and this will tell you like in which order arrays are getting processed. Okay, as I mentioned, remember, the order is going to depend on the height. So nodes having the smallest height will be chosen first. Okay, as simple as that. So as you can see, this is happening. Okay, so remember, just know one thing. the sorting in a heap always happens from this. Okay, so this will be compared first. If this is same, then this will be compared, and if this is also same, then this will be compared. Okay, so I'm just telling this so that you can like analyze what is happening here. See this part here, x and x are same. Okay, here x and x are same, here height is same, here this also height is same. So the difference came here. So y whichever is 0, that will be chosen first, y whichever is larger will be chosen next. Okay, and so on. So I hope now you understood how this heap works. This question is totally around the topic of heap. Let me tell you that I tried multiple like stuff using graph. Okay, that will be definitely a lengthy one, and at the same time my solutions I was not able to you know clear all the test cases. It was getting time limit exceeded error for me. Okay, for that reason I'm not showing you that solution, but again, this solution that I showed you, it's the best solution available. Okay, and yep, as of now this is the only solution which is clearing all the test cases without getting exceeded because of time limit error. Okay, so fun, that was all for this particular video. So in this video what we learned, see, this is all about your imagination, how you're imagining it. Okay, so what I saw, like told you initially in the starting of the video, that simulation, that is, let us say that the raindrops are falling. What will happen first? First it will go and fill the cavity which is there in the lowest level. So like I tried that simulation approach, that would, what will happen is, choose a node which can act as a cavity, and then start the bfs or a dfs, and then like keep proceeding to all visit all the nodes. Whichever node is at the bottom, that should be filled first. Okay, something like that. That part is something that I will definitely work more on, and if I'm able to get a solution for that, I will show that also. But currently this is the working solution, and I'm really happy that this is the hard question and we were able to come to the solution. Remember, like, see, designing the solution is not that difficult, but to get that logic, okay, to get the idea of using a heap, that is something that is not easy. For that reason, this is not a hard question. Let me tell you, if you can, like, if you tell a student, okay, this is how you have to do it, I'm sure he will be able to code it, because see, this is nothing rocket science that we're using here. Okay, the only thing that is difficult is to how to get this idea. Okay, that we have to start from using a heap, and then we have to keep popping based on the height. Then from the height, like, we have to make them act as a boundary and so on, like the adjacent will now act as a boundary. Okay, we'll use the visit set and all that. So this is something that I am sure that you will not be getting the idea. So yep, this is all for today. For your, like, for you to imagine what is happening, I have done these outputs. You can go through them. Okay, and while submitting, just comment the print statement so that the outputs are not generated for that final test cases for which you are going to submit the solution. Okay, so just ensure that part, and other than that, yeah, we should be good. So if you see the example number 2, see this part. So there are 9 cavities here, and one of the cavities is going to be a slightly deeper one. Okay, so see this part. There are 9 cavities, so 9 units of water will be stored, and one of the cavities, as you can see, is going to store 2 units of water. So for the reason, its answer is 9 plus 1 10. So here we are getting 10 as the answer. Okay, you can go through this, like how this simulation is happening, and please try to understand this works, because see, this is going to be a FAANG level question. Let me tell you this very frankly. See, this is the exact level where you can see this is the exact FAANG level question. Okay, because here it's all about finding the logic. Okay, see, it is easy to solve. Okay? Like, if I can tell you this logic, I'm sure that like around 80 to 70% of you will be able to code this code. Okay, but the difference is coming, like, how to get this logic. This is something that you will not be getting. Even if I tell you, like, use a heap solution, still you may not be able to, like, find this logic. Okay, so this is where you will have to work on, like, how to imagine things, and how to once we get a hint, how to build upon it. Okay, so that is something that will be important in a FAANG level interview, because you'll have to keep asking certain questions, like, okay, in this case, what should I do? For example, see, in this question they did not mention, for example, once the grid is over, okay, outside the grid what is there? Okay, whether it's empty space, or we can say like a boundary, invisible boundaries, or something like that, they have not mentioned here. Those points you are supposed to ask and get a clarity on, otherwise your solution will be totally wrong. You have not asked those part. Okay, that is not mentioned here, but you are supposed to ask those things. Okay, remember those things. Yep. So based on this only, you will be judged, and your, like, the ranking that you will get. Okay, after your interview, face to face interview, those marks, or like, okay, whatever you call it, marks or rank or whatever it is, then that will generate based on, like, how many questions you asked, if you are given a hint, whether you are able to build on that hint or not, and all that. Okay, so please be very thorough with all the things, and yeah, ultimately it's all about ideas, whether you are able to click that idea in that particular moment of time or not. Okay, so yeah, and that was all for this video. If you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. Okay, see you tomorrow. Thanks a lot.